Alright, so welcome to this short video on how Newton's law can be used to explain how lift forces are generated. So let's take a quick look at an airfoil here. And as part of this video, we're actually going to define lift and drag. So here's my airfoil, and it's going to be in a flow that's coming towards it with no angle. So it's just going to be a parallel flow that's aligned with whatever our axis system is, like this, X and Y. And I'm going to draw on here a lift force, L, and a drag force, D. And by definition, I'm just going to write it down here. So lift is perpendicular to V infinity, and I'm just going to call this now V infinity. So V infinity representing the flow far upstream, and P infinity, the pressure over here, is equal to P atmospheric. So this is far away from the airfoil, we call infinity. That's just a notation in aerodynamics. But what we can see is that this is going to be perpendicular to this direction like this. So I'm just going to put a dotted line here so it's very clear, and perpendicular like this. So if this wing or this flow field were to change direction, then the lift and drag vectors would have to change to remain perpendicular, and drag in this case is parallel to the flow. So perpendicular and parallel to the flow. So let's just write down here, drag is parallel to V infinity direction. So there's my lift and my drag defined. And then the other thing we might define is a moment. So for a 2D wing, we might have what's called a pitching moment, M. Like this. So that would indicate how the nose or the moment is pushing the nose down or the moment is pushing the nose up for your particular aircraft or vehicle. So there's lift and drag, and what we're going to do now is we're going to try and determine how to use Newton's law to talk a little bit about these lift forces. So we'll come back to drag forces at a later time in a future video. But lift forces, basically what's going on here is that as this flow approaches this airfoil, it's going to create a flow field around the airfoil, and the airfoil is actually going to have an impact on the fluid going around it. And I'm just trying to draw this somewhat carefully here so it actually aligns with Newton's law a little bit, like this. And what we can see in this case is the flow started off far upstream with a direction that goes this way. So this is V infinity, and it has a direction that's horizontal. In this case, we have a V downstream, or V after the impact with the airfoil, or after it's interacted with the airfoil. The velocity has actually got some downwash or some downward motion to it. So what we can see now is that there's a component Vx, and there's also a component Vy. So what we can imagine now, right, is that this wing has actually had to push down and pull down the flow, right? And as we push down on the flow and pull down on the flow, what happens is that the wing, or the actual particles of fluid, push up on the wing and pull up on the wing, right? So these particles of fluid here that are going by are actually pushing up on the wing and pulling up on the wing to make it go up. And the net effect of this deflection is going to be this lift force here, right? So if we push down on particles and pull down on them, and they, in response, pull up and push up on us, we're going to get pushed up as an airfoil in this case. So the question is, how does this all work and relate to Newton's law? Well, relatively simple, I think, right? So if we take a look at the momentum, so force in this case for Newton's law is equal to mass change in velocity with respect to time, like this. So if we take a chunk of mass over here in the airflow, so we've got a chunk of air, and we look at how the velocity of that chunk changes when we go from the front of the airfoil to the back of the airfoil, or how the momentum is really what's going on, is this is momentum. How the momentum changes, well, in order to make this block go from horizontal to a downwards orientation horizontal in this case, what we would find is that we would have to impart a force on it. And that force in this case is the lift force, right? So we've changed the direction of motion and therefore changed the momentum or changed the velocity with respect to time of those fluid particles. And the result is a net lift force. So this is probably one of the most simple explanations of lift, that basically we're taking objects and imparting changes of momentum to the fluid using that object, and as a result, the fluid is imparting a force onto the object. So hopefully that's kind of interesting to you. We can talk a little bit more in detail how that works, but I wanted to just introduce this topic in a quick short video clip.